In this video, I'd like to talk about a really quick tip about working with pointers and arrays when passing them into functions. So these are sort of like a pointers as function arguments discussion. So one thing that's really common is we'll see a function that looks like this. Whatever function it might be, and it could take a pointer to an array A and then a size along with it. And really what this is telling us is two things. One is here's a pointer to this array in, let's see, this array in memory. Something might look like this. And then here's the size of this thing. So in this case, it'd have a size of 2, 3, 4, 5, right? And then we can go in here and we can write our for loops for int I equals 0, while I is less than size, I plus plus, and then we can do whatever logic we want to do, dot, 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 with this. So an interesting thing about this is we have this array A, 1, 2, 3, 4, 5, 8, 33, whatever it may be, dot, 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 dot. And this thing may be big and small or whatever, right? And if we are using this function recursively, sometimes what we want to do, or even not recursively really, but sometimes what we want to do is actually have a function like this only look at a portion of our data, maybe the first half or the second half of our array. If this is something like merge sort, we might want to split this thing into the first and second parts. If this is something like a binary search, we might be sort of traversing through this thing in some more formalized fashion. And the interesting thing about this is you can sort of, it's not really tricking, but it's kind of like tricking this function into only looking at one half or a subset of this array. Let me show you what I mean. This array in memory, let's say it looks something like this: 23, 32, negative 8, 16, 24, negative 3, right? And I was writing some function that, let's say that this is a sort function. Doesn't matter what kind of sort function it is. Say it's a sort function, and it takes two things. It takes the array, the pointer to the array, wherever this is in memory, and then the size. So by default, it would be this location in memory, or this pointer, this memory address, and a size of 1, 2, 3, 4, 5, 6. And then as this function executes, it would be looking at this entire array. Well, here's the interesting thing. What happens if I were to instead say the size was 3? Well, inside that for loop that I originally had in I equals 0, well, I is less than size, dot, 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 in here, and I'm doing something a bracket I, I'm doing whatever logic I need to do. This function would only think that this array has a size of 3. So really it would just look at these 3 elements and then be done. So if I had a sort function and the challenge was, well, only sort the first half of the array, well, I could really easily do that. I call the exact same function. I pass the pointer to the very beginning of, as I normally would to the array, and I just give it the size divided by 2. I just give it half the size. If I only want to sort if I only want to sort the first 10 elements, I could say, you know what, the size is equal to 10, or whatever method I want to use, which is really interesting because we're kind of tricking this function into thinking that this array is actually smaller than it is, when in reality it's not. Another interesting thing about this is this location in memory, this pointer. This pointer could be any location in memory. If the challenge was I want to sort the second half of the array, well, let's give it a pointer to this location in memory. Let's make this function think that this is the entire array. And how would we do that? Well, we'd say we need a pointer, which is a plus the actual size of this thing divided by 2, right? We wouldn't dereference it in this case, right? But we're doing a little bit of pointer arithmetic. And this is what I would pass into my function. Take my array and then add half my size to it. In this case, it's 3, and give me a pointer to this location. And then for my size, I'd say, well, the size of this thing is now 3. 1, 2, 3, right? And so it would be size divided by 2 is what I'd pass into here as well, right? And this is how I could solve the problem of I want to sort just the second half of the array, or just do logic on the second half of the array. If you told me that you want me to sort the entire array, except for the first two elements and the last two elements, okay, that's fine. I can do that too. I will pass into this function a pointer that is at this location, and I will tell it that the size is whatever the normal size is minus 4, 2 for the front and then 2 for the back, right? In which case, what I would pass into this function would be a plus 2 to get a pointer that's moved over by 2 to this location. And then the size would be the actual size minus 4. This, if I was calling that into a sort function, it would sort this portion of the array, because that's all the function would be looking at. So this is a really interesting technique, and a technique that is used really commonly, especially in recursive functions, where you're sort of doing logic on just different parts of the array. You'll see this in quicksort and in merge sort, especially when you're sort of dividing this into sort of sub-arrays. And you don't want to create brand new arrays in this case. You want to do this in place so that you're not creating, you're not using more memory. So in those cases, you'd essentially say, well, I want to split this thing into 2, so I'm going to use my A pointer, the original memory location, and the size divided by 2. And then for the second set, I'm going to do A plus the size divided by 2, which is a pointer at this location, and the size divided by 2 as how long the second array is. So really interesting technique here, and it's all just sort of manipulating these two variables here, and manipulating these functions in our parameters into pointing and looking at various locations in memory that, this is our memory. We can do whatever we want with it. But as far as this function is concerned, it has no idea that this other data even exists if we're not passing it in. So really interesting technique here.